Hi, welcome to all of you. In this particular video, I am going to explain a gradient descent algorithm, algo in simplistic form. So in last video, we have seen that what is gradient descent algorithm. In this video, I am going to extend the same concept and I will try to explain or prove in a simplistic manner. So let's start it. So what we have seen as of now, we have a error function which is nothing but half summation n equal to 1 to capital N w0 plus w1 xn minus yn whole square. So this is our error function and we have to minimize this error function to find out the optimal w0 w1 which gives a minimal error, and then we have to pick that the linear regression model for our prediction. So now let's prove this one in this manner. So let's suppose we have a line which is nothing but w0 plus w1 x. So this is the linear regression model, and let's assume that we have picked some w0 w1. For now, just forget about this w0 w1. What I am saying here is that this y is a dependent variable on this x independent variable, and the w0 and w1, so this is nothing but a slope of a line and this is intercept. So let's consider this is x-axis and this is y-axis, and we have a data point like that. So what this line is saying here is that this line will pass through this, or this could be this also, depending on the w0 and w1 what we have picked up. So this is for this particular line, this linear regression. But what I am saying that I want to pick that linear regression where the intercept doesn't matter. So doesn't matter means what? So we have a data point like this, like something, and our linear regression model is passing through origin. It's not intercepting in y-axis, like you can see here it is intercepting. So this is the intercept. So what would be our linear regression model for this second graph, and this is the first graph. So for this second graph we will be having just w1 x, because w0 is nothing, there is no intercept here in this graph. So for now let's consider this is the linear regression model. So what would be an error for this one? If I want to find out the error for this particular one, so what would be the error for this one? So the similarly it is half summation of n equal to 1 to n, and then in place of w0 you just put it 0. So it is w1 xn minus yn whole square. So when we have a w0 which is nothing but an intercept 0, that means that is passing through origin. So we will have this error function. So let's proceed from this particular error function, because this is having a one variable which is nothing but w1. We can say w also here because we have a one independent one variable itself. When we have a 2, then we are saying w0 and w1. Here we have only slope, so I can say w also. So let's minimize this EW, and our intention is not to minimize here. I'm just going to prove how gradient descent work for this particular error function. So let's proceed from now. So now we have found out our error function, which is nothing but w half summation of n equal to 1 to n wx minus xn minus yn whole square. And now if you see, it is a one variable, so it will come in 2 dimension. So that means take this graph, this is x-axis, this is y-axis, this is nothing but EW, and this is W. For each W we will have some loss, and this will be like that, a convex function, and we have proved this one. Now let's start. So what the gradient descent algorithm is saying, which we have already explained it, take any point any point, let's take this point. So this is point 1, and then go to the next point, which is W2. And how this W2 would be calculated? Move negative direction of its gradient. So what is the meaning of that? The first point minus eta step negative direction of its gradient of error function on point W1. So this is our actually equation, you can say, to find out the each and every step in an iterative manner. So similarly, if you go for Wk plus 1, so that would be Wk minus eta step negative direction of its gradient of error function, which is point k. So calculate the gradient of this error function on point k. So initially, so what we have to consider, two things we have to consider here. What is the impact of this eta when we pick some value for this? So this is nothing but called a learning rate also. So this is learning rate. So this will have a significance. If you pick some random value for this one, maybe very high or very less, so you will not be able to converge to that local minima, global minima. So that I will also explain you how much importance of this learning rate. So first of all, let's see what is the actual meaning of this in a negative direction of its gradient. What is actual meaning in the 2 dimension, because in 3 dimension we cannot clearly visualize it. So I am just explaining in simplistic manner. So let's take this, what this algorithm is saying, that take the initial point, this one, which is nothing but W1, and move towards at eta step in a negative direction of its gradient. So what is the gradient of this particular point? Gradient of this particular point is nothing but a tangent line, this tangent line on this particular point. So tangent line for this particular point is what? So slope of this, and this one is the theta. So the slope you can calculate by using the first derivative also. So if you calculate this one, the partial derivative or dy by dx, so in respect to w, so that means if you differentiate this error function with respect to w, that also will give you slope. But in a negative direction of its gradient, what is the actual meaning of that? So when you taken this particular point, and when you are moving towards a negative direction, so what is the slope of this one? So the slope here is the theta, and if you see here, the theta is less than equal to 90 degree and greater than equal to 0. So when the theta is less than equal to 90 and greater than equal to 0, so tan theta would be greater than 0. That means some positive number. So this particular point, if you put it inside this, so see here, we have picked this particular point, we have some eta value, let's suppose 0.05, some value is there, and now the slope of this error function on a point, this one, so the point here is greater than 0, that means positive. So this is positive value, this is also positive. So when you subtract from this initial point some positive value, it will go somewhere here. The next point would be somewhere here. And similarly, if you calculate again, go to this, let's suppose in third point. So third point would be what? W2 minus eta step gradient of error function on point 2. So I am calculating for point 3. So 2 I have already calculated this one. This is the point. Now I am going for, let's suppose, 3. So this is point 2. So similarly, what I have to do, I have to take the gradient of this line on the this tangent line on this particular point, which is nothing but W2. So this will be again theta, and this also will come under this category where theta will be less than 90 degree and greater than 0, and the tan theta, if you calculate, it will be always positive. And once it is positive, so this is also positive, this value also positive, and from here if you are subtracting, so it will shrink in this direction. Now take the another scenario. Now let's suppose you have started from this particular point. Now I am free to take any point, initial point. I am taking here. Now I am starting from here. What would happen? So you if you want to find out the next point, which is nothing but this is W1, W2. So how you will be finding this W2? W1 minus eta is nothing but 0.05, and the slope gradient of this error function on point W1. So as we know that the gradient is nothing but a tangent line on this point, and the tangent line, if you see here, this time it is theta, and here theta is greater than 90 and less than 1, theta is less than equal to 180 and greater than 90. And once this scenario happens, the tan theta is less than 0. So here theta, if you calculate the slope of this tangent line, it would be negative. So that means here it is, eta is positive and the slope is coming negative. So that means positive into negative is negative, and then negative negative plus. So this point, it will, this, let's suppose this point plus this particular value, so it will go somewhat. So this is the point actually. So W2 would be somewhere here. So W2 will go in this direction. Similarly, if you go for W3, so you have to do the same thing for this point, so it will shrink in this direction. So this is actual meaning of this in term of 2 dimension. Now let's consider that we have picked something eta value very high. What would actually happen it? So now if you see here, you have W1 point, and if you want to pick W2, so which is nothing but W1 minus eta gradient of error function on point W1. Now let's suppose this we have calculated 0.05. W1 something is there, some positive value is there, because if you take this one or this one, it will be positive in this y direction. And then if you pick eta, let's suppose 10,000, some value is here positive. So what would happen actually in this positive, if you multiply this 10,000 to 0.05, so it is nothing but 500, and it will be cancelled. So you are adding 50. So you are actually subtracting some value from this particular loss, 50, let's suppose. So what would happen, the next point would, and so that means the point would shift in this direction, in this direction. And similarly, if you go for this one, and if you take another, let's suppose 10,000, or maybe bigger value for this one, so what would happen, again it will jump from here to here. So what is the actual meaning is that we have to calculate this eta value experimentally, so that it will converge it in a local global minima. It should not go to divergence. That means it should not oscillate from here and there, like it is coming, point is coming this side and then this side, then this side and this, then this side. If you take bigger value, it will jump here and there. If you take very less value, then it will convergence will take very high iteration. It will not converge very soon. So the eta value we have to calculate very experimentally, otherwise it will not converge, rather it will diverge. And if you take very less value for eta, it will take very high time to converge to the global minima. So the importance of this eta is very high, and if you do not calculate this and select this value uh, carefully, then it will be a problematic one. So I hope you would have understood this one. If you have any question, please put it in comment box. I will try to answer as much as possible. Thank you for now.